All right, today we're going to go over 512 notes of fundamental theorem of algebra. So here's a little warm-up question for you guys. You got a graph and says, what are the solution roots to the following functions? So roots, solutions, these are all x-intercepts, okay? So if you think about it, you're going to look at the places where x is crossing, which will be right here, and right here. So what are the roots and solutions of this function? It will be x when it equals -5, when x equals -1, and when x equals 3, okay? Now, can we determine what kind of function it is? Is it quadratic function? Is it cubic function? Is it quartic function? It is a cubic function because it has 3 zeros, right? 3 places where the graph crosses. So the degree of this function would be x cubed, following up with the rest, okay? Now for number 2, find the solutions to the equation. Again, remember, so far we only did 2 parentheses as factors for a quadratic function. Well, now as the polynomials, we're going to have more of them. So if we're looking at this, we got 1, 2, 3, 4 different factors. Now we are going to equal them each to 0, just like we always do to solve for x. So x plus 2 will equal 0, where x will equal -2. X minus 5 will equal 0, where x will equal 5. X plus 4 will equal 0, where x will equal -4. And lastly, 2x minus 5 will equal 0. We'll move the 5, so 2x will equal 5. Okay, and then we'll divide it by 2. X will equal 5/2. Okay, so that tells me, all right, that I am going to have 4 zeros, okay, where -2, 5, -4, and 5/2. So that tells me that this polynomial will be a quartic polynomial, okay? So it would start with x to the 4th and then continue with the rest. All right. So today, after today, you guys are going to be able to use fundamental theorem of algebra to find zeros of a function from a factor form and connect the zeros to the graph. So what is fundamental theorem of algebra? It is a degree of the function that is equal to the total numbers of solutions of the function if duplicates are counted as separate solutions. So what does it mean? It means as many zeros or solutions or x-intercepts as we have, it will determine the degree of that function. So, for example, if x to the 4th, I will expect it to have 4 different answers of a solution, right? 4 different places where the graph will cross x-axis, okay? So, example first, we got 1, 2, 3, 4 factors, which means we're going to equal them all to 0 to solve for them. So x plus 2 equals 0. X will equal -2. Here x will equal 5. Here x will equal -4. And we already know from a warm-up that here x will equal to 5/2. I'm sorry. It was 5/2. Okay, it's the same question as the warm-up. 5/2. Okay. So now let's plug them in. All right. So let's just say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's our graph. This is our x-axis. So as I am talking about solutions, I got -2, which is here. I got 5, which is here. I got -4, 2, 3, 4, which is here. And I have 5/2, which is really 2 1/2, okay? So it would be like somewhere here. All right. So again, looking at that, I got 4 zeros. So I would say the degree of my function, it's 4. Okay. So if I would have started function, it would be something like x to the 4th and so on. All right. Now for number 2, we have to equal every single part to 0. Okay. So that means that 3x in the front has to be equal to 0. X squared factor plus 2 has to be equal to 0, and x plus 5 has to be equal to 0. Okay, to solve. So 3x equals 0, x equals 0, so that's one solution. Okay, x squared plus 2 equals 0. X squared equals -2. Okay, so if I square root this, what is that going to give me? An I, correct. So x will equal I root 2 plus or minus, okay? And then the last one, x plus 5 equals 0, so x will equal -5, okay? So again, if I am plugging those in, I'm going to plug in 1, 2, 3, 4, 5, so -5 right here for one solution. I'm going to plug in 0 for another solution. Now, am I plugging in plus or minus I root 2? No, I do not, because it's an imaginary solution, okay? It's not a real solution, so it will not apply on x-axis, right? This one will not be graphed. We only graph real numbers, okay? So, what would be the degree of the function? Okay, it would still be fourth degree. Okay, why? I got one solution, which is -5. I got 0 as a solution, which is 2 solutions, and then I have plus or minus I root 2. That's 2 different solutions, right? So that makes it a fourth. So this would be a degree, would be 4. All right, next example. So this is a cube function. So what we can do is we can try to take some stuff out, do a greater common factor, and get it to a point where we can equal those factors to 0. We are always trying to get it down to, factors. And so what we can do is we can look and see, does 4x cubed, 26x squared, and 40x has anything in common to make it more suitable, okay? Let's see. So yes, it does. I can take 2x out of each. Each of them has an x, and each of them is divisible by 2. I can't take 4 out because 26 is not divisible by 4. So if I take this out, my new function is going to be 2x times, okay, now what's left? 2x squared here, because I'm taking 1x away, okay, plus this is going to be 13x, and then plus 20. All right, now this is more suitable. I can do 8 times c, okay, and find 2 factors to multiply to, let's see, 40 and give me 13. All right, that will be 5 and 8. Okay, so now I can change that. The 2x still stays outside. Okay, we're not gonna let it disappear. And now I'm gonna have x plus 5 and x plus 8 now on the inside, and instead of this quadratic equation. Now remember that because there's a 2 here, okay, the leading coefficient, I got to divide both sides by 2. Okay, so my function is going to be 2x. Okay, 5 does not divide by 2, so I'm going to put it in the front, 2x plus 5. And then 8 does divide by 2, that gives me 4. Okay, now to solve, I'm going to equal them to 0. And I'm going to equal all 3 parts. So 2x equals 0, the parentheses 2x plus 5 equals 0, and x plus 4 equals 0, okay? So 2x equals 0 divided by 2, x will simply equal 0, okay? 2x plus 5 will be x equals -5 over 2, okay? And then x plus 4 equals 0 will be x equals -4, okay? So again, negative right here, okay? So these are my 3 solutions. So if I determine what degree is my function of number 3, is going to be to a 3rd degree. Why? Because I have 3 solutions that I solved. I have a 0, I have a -5 over 2, and I have a -4. Now again, I can graph it, and it's going to be -5 over 2 right here. That's 2.5. 5 over 2. I also have -4. And I also have 0. Okay, so I got 3 solutions. 1, 1, 2, 3. In 3 places, this graph will cross x-axis. Okay? Okay. Now I'm going to erase all that, so please, if you need to write it down, pause the video. All right, and for the second example, the 2x squared minus 50, we need a factor first. So again, I am going to take the 2 out, okay? I'm going to divide this function by 2. So this is going to be 2, now x squared minus 25, okay? Because I divided both of those items by 2. Now I put myself in a position, this is a quadratic equation, but as you notice, it's missing a b. So I can use a square root method since I have 25 and an x squared to square root both of them. I don't know if you guys remember. Or you can simply equal it to 0. Either way, it's fine. Okay, so you're going to have 2 equals to 0, which is not true. Okay, and then you are going to have either x plus 5, x minus 5, okay? Because again, I'm square rooting the x and I'm square rooting the 25, where I'm going to equal them to 0. So one is going to be -5, one is going to be 5. Or I can simply take x squared minus 25 in a parenthesis, equal it to 0, move 25 to the other side. X squared will equal 25, and then I'm going to square root both sides where x equals plus or minus 5. So either method is fine. So you get 2 solutions only, because 2 will never equal 0. So that's not a solution. And so you're going to get plus or minus 5. Okay, so -5 here and +5 here. So for your degree, this function will be to a second degree. Okay, you will have 2 places where x crosses the x-axis. Okay. All right, so for this example right here, guys, just a reminder that a practice for each polynomial complete the following is that you need to figure out how many zeros does the polynomial have, what is the factor form of the polynomial, determine the zeros of the polynomial, and plot the zeros. So according to what we're looking at, we're supposed to have 4 zeros. Okay, now let's try to take something out, factor, do greater common factor, whatever. So I got 4 and I got 12, so I know I can divide both of them by 4. I also got x to the 4th and x to the 3rd, so I know I can take the smallest x's out of both, which is x cubed. If I do that, I get 4x cubed on the outside. What's left on the inside? X, okay? And then 3, right? Because the x's would cancel, and 12 divides by 4 gives me 3. All right, now this is more doable, and I can equal it to 0. So for 4x cubed equal to 0, you divide by 4, you divide by 4. So x cubed will equal 0. Okay, you cube both sides. It's still going to end up being a 0. Okay, so one of the solutions is 0. Okay, now the second one is x plus 3 equals 0 in a parentheses, which is this piece. So x will equal -3. Okay, now this it's going to be right here, -3. Okay, I can just put -3 here. All right. Now, here's when we bring up something very important. Okay, so we said that our degree is 4, right? So I'm supposed to have 4 zeros. But I'm only showing 2. Okay. Now, that's when we bring up that a 0. Okay. It's going to be here 3 times because this was x cubed. So in this solution, which is 0, really there is 3 zeros in the same point. Okay, because this is what our function, it says right here. This was cubed. That means that the solution has 3 the same answers. So this is 3 zeros, and then this one was 1. Okay, so that's why it makes it a 4. All right, so again, because we had the x cubed right here, that means I got 3 x's. Okay, when I took a cube root, okay? Not a square root, cube root. That means that was really, I could write it like this, guys. I could write that x equals 1, 2, 3 zeros, okay? So in 1 point, I got 3 answers in there, and then -3, it's another 0, which makes it a 4. All right, the same practice. How many zeros do we supposed to look like we have? 3. So it's supposed to be degree 3 and 3 zeros. So let's see how many we're going to see, okay? So again, first what we need to do is we need to take something out to get it down to quadratic function or to a linear function, okay? So we can divide each of these, do not have a number to be divisible, but they do have an x that I can take out because I can always take out the smallest x that here, okay? So because I got 3, 2, and 1, I can take 1 out of each. All right, so x will come out, what's left? X squared plus 3x plus 2. Now I can find two factors and multiply to 2 and add to 3. That's going to be 2 and 1. So again, x plus 2 and x plus 1 here equals 0. Now again, I can equal them all to 0, okay? So x will equal 0. X plus 2 will equal 0, which is x equals -2. And then x plus 1 will equal 0, which equals x equals -1. So it looks like I got 3 real number zeros, which is what I expected. I got a 0, I got a -2, and I got -1. So these are my zeros right here, okay? All right. All right, guys, and here, let's see. We are simply matching which function will go to which box, let's just say. So let's see, let's make it bigger so maybe it's easier for us to see it. All right, so from just looking, I would assume that the graph itself, it was supposed to, let me switch it to a pen. The graph itself, it's supposed to have 1, 2, 3 zeros. If I would have moved this graph, I would move this to a column what it's 3 zeros. Again, that is what the expectations are from what I read. Uh-oh, it disappeared. Yeah, sorry. Okay, so I would move it to a 3 zeros. I'm just going to write it because it seems like my thing is not working. This will be at third degree with 3 zeros. Okay, now this graph right here, the second graph, if I look at it, it looks like it has 1, 2, 3, 4. So this would be 4 zeros expected to the fourth degree from just reading. Okay, now this, the first one right here, 3x squared x plus 1, it looks like I would equal 3x squared to 0, which would give me x, I will divide it by 3, divided by 3, x squared will equal 0, and then I would get x plus or minus again, because remember, when equal plus or minus 0, so you will get 2 zeros from this 3x squared, because you got 2 x's, and then you will equal x plus 1 to 0, and you will get x equals -1. So a total of the first function, you would have 3 zeros total. Okay, so again, this function will go in here because again, this has 2 zeros and then there is another x that has 1. Okay, a second function right here, 1/2 x squared plus 5, right here tells me 2 zeros, so I would put it under 2 zeros because again, if I solve it, I'm expected to get plus or minus an answer, which would give me 2 zeros. Okay. 4x cubed looks like 3 zeros. Okay, so again, if I would have factored it, and you can guys work it out as well, that would give me 3 zeros because that's what it's indicated. This one right here, 2x squared plus 7x5 minus 6, you have to put it into a standard form. So remember, highest degree of 5 goes first, okay, plus 2x squared minus 6, which means that this function will go under 5 zeros according to the leading degree of that function, okay? Because again, we got a 5 right here, all right? This one looks like it's a 4. So negative 2 to the 4th plus 7x plus 13. Because again, this right here would indicate the degree that and how many zeros the function should have, okay? So all of these 3, 2, 2. Now, this one right here, it's a little bit more difficult. But again, if I would have equal it to 0, I would equal each term. So 5 equal to 0 does not exist, okay? X squared equal in x squared plus 3 equals 0 would give me 2 answers, okay? They would be an imaginary answers because if I move the 3 to the other side, this 3 will become negative, and that would have an I in it, so I can't graph it, all right? X minus 4 will equal 4, and x plus 7 will equal negative 7. So really, in this one, how many zeros would I have? Well, I would have 4, negative 7, and 2 imaginaries, right? Because remember, this part right here, to make it clear, this part right here, okay? This part right here, x squared plus 3, if I take x squared plus 3 and equal it to 0, and move the 3 to the other side, x squared will now equal negative 3. When I square root it, x will equal plus or minus I root 3. That's 2 answers here. Okay, so I got these 2 answers, and then I have x equals 4 and x equals negative 7. So that would be 4 of them, all total. So I would put it under 4 zeros, which would be in a column right here. So this would be 5x squared plus 3 times x minus 4 times x plus 7. So that function will go right here. And then again, the last one right here, how many x's do I have? And sometimes, you know, when you can actually predict it by just looking at it. So I would have 1x here. I will have 2 x's here, 3, 4, 5, okay? So I would put it under 5 zeros. Because if I equal them all to 0, okay, I'm going to probably have to write it on the bottom. All right, so again, I would have, if I count the x's, how many did I have? I have 1, 2, 3, 4, 5. Okay, so x minus 2, oopsie. So x minus 2, and x minus 7, and x plus 3. Okay, so again, if I wanted to work it out, I could take negative 3 over 4x and equal it to 0. X will equal 0. I would do x plus 1 equals 0. X will equal negative 1. I would have x minus 2 equals 0. X will equal 2. X minus 7 equals 0. X will equal 7. And x plus, what was the last one? 3. Okay? Equals 0. X will equal negative 3. So again, I have 1, 2, 3, 4, 5. 5 zeros. Okay? 5 roots. So that's where I count. 1, 2, 3, 4, 5. All right.